If someone once told you that atoms are like tiny solar systems, with electrons neatly orbiting a central nucleus, they lied to you, and quite convincingly, I might add. But don't worry. You're not alone in this. That image of perfect little orbits is still stuck in many people's minds, passed down from school textbooks, even though it's more full of holes than a kitchen strainer. The truth? Quantum physics completely shattered that idea. And what science has uncovered over the past 100 years will flip your brain inside out. Everything, absolutely everything, we perceive as solid, structured, and reliable. Position, speed, even the very reality of things, might be nothing more than a convenient illusion. And the most fascinating part? This isn't a movie plot. This isn't some internet conspiracy. This is pure science, bold, strange, and brilliantly approved by the greatest minds of the century. Today, you're going to understand why Werner Heisenberg became a nightmare for classical physics teachers. How the uncertainty principle defied traditional logic. And why the stability of matter itself depends on uncertainty. Get ready. We're going from the familiar world of the visible into the weird, wonderful quantum domain. We'll pass through atomic models, electron orbits, and uncover how quantum reality is nothing like our everyday experience. Because what seems impossible might just be happening right beneath your feet. Have you ever stopped to think how everything around us seems perfectly in place? A ball bounces. A car moves. And we assume we can predict it all. Where it started, where it's going, and how fast. This illusion of clarity shapes our daily lives. But what if I told you that certainty is just a comforting lie? In the early 20th century, a few physicists began to suspect something strange. Behind this clean, ordered surface, there was a well-hidden chaos. A world where position and speed weren't clear-cut. Quantum physics revealed that in the microcosm, the rules are completely different. And quantum reality laughs at our obsession with predictability. Apparently, knowing everything at once is impossible. For centuries, classical mechanics reigned supreme. With it, we predicted eclipses, launched satellites, and calculated the perfect golf swing. The universe seemed like a finely tuned machine, obeying clear, absolute laws. But when scientists started zooming in on atoms, that machine broke down. The behavior of electrons inside atoms simply didn't fit the old formulas. Particles weren't behaving like tiny planets at all. The atomic model, when viewed through a classical lens, made no sense. It was like trying to use a paper map to navigate space. It just didn't work anymore. For a long time, people imagined electrons spinning around the atomic nucleus, just like planets circling the sun. Sounds elegant, right? But here's the problem. If electrons really moved like that, they'd constantly be losing energy. Eventually, they'd crash straight into the nucleus. The result? Matter would collapse. And let's be honest, you and I wouldn't be here to talk about it. This paradox trapped scientists in a corner. The classical atomic model predicted an unstable universe. One that clearly doesn't match reality. Something had to be wrong. Or rather, something was missing. And it was that uncertainty that cracked the door open for a revolutionary new perspective. Enter quantum physics. That's when a young German physicist stepped into the scene. Werner Heisenberg. And he decided to face the mystery head-on. Instead of trying to squeeze electrons into classical rules, he asked a daring question. What if electrons don't have a fixed position or speed? Crazy, right? But it explained exactly what no one else could. Heisenberg proposed that electrons behave more like a cloud of probability, spread out in regions where they might be, but never exactly where they are. Trying to pinpoint an electron? It's like trying to locate the center of a moving blur. With that, the concept of quantum reality took a sharp turn. Uncertainty wasn't a flaw in measurement. It was a fundamental property of the microscopic universe. This mysterious blur became one of quantum physics' most iconic ideas: the uncertainty principle. In simple terms, you cannot know both the exact position and the exact speed of a particle at the same time. The more precisely you try to measure one, the fuzzier the other becomes. It's like trying to decide: do you want to know where the bird is? Or where it's flying to? You can't have both. This wasn't just a technicality. It flipped our entire understanding of the quantum world. Uncertainty stopped being viewed as a measurement failure and started being recognized as a built-in feature of nature itself. It's like the universe whispering to us, "Hey, relax. Not everything needs to be under control." And the most surprising part? That lack of control is exactly what allows things to work. Here's the twist. It's because of uncertainty that electrons don't crash into the nucleus. It's because of uncertainty that atoms are stable. You heard that right. What once looked like a problem became the solution. Without fixed atomic orbits, electrons exist as scattered probabilities. And this prevents them from constantly losing energy. The result? Matter holds together. Which means no uncertainty principle, no you, no me, no warm coffee in the morning, even the solid table under your elbow. It's stable because of this beautifully chaotic principle. Quantum reality may seem like madness, but it's the reason anything exists at all. The irony? The universe is stable because it's uncertain. Go figure. Now, maybe you're thinking, okay, but that only applies to atoms, right? Actually, no. The uncertainty principle is universal. It applies to everything, from subatomic particles to bowling balls. The only difference? In our everyday world, the macrocosm. Quantum effects are so tiny, they vanish from sight. That's why daily life feels so stable and predictable. Objects are just big enough to hide the quantum chaos beneath. But it's there, silently shaping the foundation of everything you know. Quantum uncertainty is the backbone of the order you see. And the more we learn about it, the more mind-blowing the universe becomes. Werner Heisenberg didn't just leave us with an equation. He left a revolution. He helped build quantum mechanics and forever changed how we understand the universe. But his story didn't stop with science. During World War II, Heisenberg was involved in Germany's nuclear program, sparking intense debates about his true motives and ethics. To this day, he's a figure that inspires both admiration and controversy. He wasn't just a scientist. He was also a philosopher, constantly reflecting on the limits of human knowledge and the very nature of quantum reality. His life reminds us, sometimes, to understand the universe, we must face questions as deep as space and time itself. And that, let's face it, sounds like something out of a movie script. Who would have thought that uncertainty is the very thing holding everything together? In a world that demands answers, where we're pressured to be sure of everything, quantum physics teaches us something profound. Sometimes, living with doubt is the wisest path. And if the universe is made of probabilities, maybe it's time you gave yourself permission to explore your own. What would your life look like if you embraced the idea that not everything needs to be under control for things to go right? What if, instead of fearing the unknown, you leaned into it with curiosity, not fear? Science didn't come to kill the magic in the world. It came to show us that the real magic happens in the tiniest, invisible details. If this video made you rethink what's real, don't forget to subscribe, turn on notifications, And share it with someone who still thinks they know everything about atoms. Because knowledge is only the beginning.